dy dx plus y equals sine x. There's a 1 hiding here, so I just put it in explicitly. And we'll circle this. This is our p here, isn't it, the number of y's? So here then, the integrating factor, fairly straightforward to work out. It's equal to e to the integral p, which is 1, dx, which is the integral of x. 1 is x, so it's e to the x. So multiply through by e to the x all the way through then, e to the x dy dx, plus e to the x times y is equal to e to the x sine x. Now we can circle the u and the v. So let's do that. That's always going to be u in that position there, that's always going to be v. So we can concentrate our efforts on this now. So here, d by dx of u times v, e to the x, times y is equal to e to the x sine x. So integrating then, gives the integral of the derivative is just the object itself, e to the x times y, and that's equal to the integral of e to the x sine x, which is a standard integration by parts integral. So we'll do that now. Let's let this be v and this be du. Here's our grid, so let's just put that in here. So v is sine x, and then du is equal to e to the x. So dv will equal cos, and u will equal e to the x. Okay, so I'm going to let j equal this integral then, because it is a sub-problem, e to the x sine x dx. And I'm going to draw a line across the page so that we'll come back to this original problem, just to remind me. So, what have we got then? This was v, this was du, so let's work out this then. So, uv, which is these two, no it's not, it's those two, I'll get it right in a minute. uv is those two, e to the x sine x, minus the integral of u dv, isn't it? So e to the x cos x dx. And then what I'm going to do is I'm going to do this sub-problem now, because we've gone from e to the x sine x to an answer involving an e to the x cos x. So j was equal to that. I'm going to circle this now, not with the minus. I'm just going to circle this integral and call it capital K. And I'm going to draw another line across the page. I'm going to work this one out. And you'll see why I've done that in a moment. So let's do that then. K equals integral e to the x cosine x. It's not much more now. Let's just tie this together then. Let's do our grid as per usual. Same approach as before. So this would be v and this would be du. And v is cos x. And then the du is equal to e to the x. So dv will equal sine x then, with a minus. And then u will equal e to the x. So let's put the pieces together in the jigsaw. It's uv e to the x cos x minus the integral of u dv, isn't it? So that's e to the x sine x with a minus. And the minus will make that a plus. But this is just j. This is e to the x cos x plus the j we started with. So now we need to piece this together. So draw another line across the page. Now we need to piece it all back together, don't we? So what does j equal then? Well, j is equal to, so let's go back up slightly and piece it all together. There was j. It was equal to this minus k. So I'll put that down first of all. Then it's equal to e to the x sine x minus k. And now we know what k is, we can put it in. and k was equal to then this stuff here. So that's equal to e to the x sine x minus k, which was e to the x cos x, minus j in a bracket, which is equal to e to the x sine x minus e to the x cos x, and then the minus and the minus make a plus j. Oh, that was a plus j in here, so that becomes a minus j, otherwise we'd have been in problems, wouldn't we? So that's now a minus. And now move the j over to be with the other j that's here on this side. So that implies then that 2j equals e to the x sine x minus e to the x cos x over there, and then j at long last. So j will equal to then, divide by 2, it's a half, e to the x sine x minus a half, e to the x cos x. There we go. Draw a line across the page just to help us remember that we're on a sub-problem. So we know j now, don't we? So let's go back up to our original problem, have a little look at it, and then we can piece it all together, can't we? So integrating gives, yeah, so we had that, didn't we? Here it is, here. E to the xy, there it was, is equal to j. E to the x times y was equal to j. So e to the x times y is equal to j, a half. This integral, e to the x sine x minus a half e to the x cos x. Now we were doing an integral as a subproblem, but when we do an integration we have to put a plus k at the end. So there's our problem done then. So that's that. And then you can divide by e to the x all the way through. And I'm going to do that without wasting much space. So I'm going to just overwrite this line now. So let's just get rid of this. And then I'm just going to put implies. So I'm going to divide by e to the x all the way through just to show you what the final answer looks like. Divide by e to the x there, here, here, and that'll be cos, and divide by this by e to the x, and it's a minus e to the x, and that will be the final answer. Half sine x minus a half cos x plus k e to the minus x is the final answer. Okay, good.